Hey kids, I'm so excited you're here to Mr. Patrick's Laboratory. We're going to have a great time again today. Man, I can't stop looking at this one we did yesterday. I don't need my goggles for what we're doing, so I'll put those aside here for a minute. We are going to do a little bit more chemistry, but not really chemicals. Last time we met, we were talking about dissolving. Remember that? We were talking about dissolving, and we did this thing called capillary action. And in capillary action, what we ended up having was these different cups, and I had 1, 2, 3, 4, 5, 6, 7. So if you tried it at home, you either had 5 or 7. You could do it with 3 cups, but you had to do an odd number. We had color, every other one color. So we had red and blue and yellow and red. And then we made bridges out of the paper towels. And we talked about capillary action was water moving up it. And so they were meeting. So red was coming into this cup and blue was coming into this cup. Look what color it made. Red and blue makes purple. You can see it, okay? And then it was going from blue into yellow. The blue and yellow were coming together and they made green, and she gets a good shot of that. You can see that green liquid in there, okay? And then you had the yellow and the red making the orange. It just takes a while. Did you try it at home? How fast was it? I don't know. I bet it was different than mine. Depends on how much water you used, okay? And so you have this capillary action that's going on. That is awesome. It worked great. This one's really cool to look at. Now, these paper towels, just as a reminder from our last episode, you can take those paper towels out. You can lay them out, maybe on a cookie sheet. Don't do it on your mom's cabinet, okay? Have your mom, dad help you. Take it out, lay it out, and you can actually let them dry out, and they're going to look sort of like you tie-dyed them. Okay, just let them dry out really good. Maybe you put them outside. You can do all kinds of cool stuff. But probably have better ideas than I do. But what we're going to do is we're going to go a little bit deeper into this dissolving. We said last time in dissolving, we're taking bigger things and we're breaking it into smaller things so we don't see it anymore. It doesn't really disappear. We just can't see it. So if I put sugar and water and I mix it up and it's all gone, when I taste it, I know it's there. If it's salt water, I can taste it salty. I just can't see it. Now, we said last time there's 3 ways to make something dissolve faster. Let's see if you remember. What was one of them? Stir it up or shake it up, right? You can shake up a bottle really good and you get it to mix it up. That was called, oh, it had a technical term, agitation. Yeah, that was it, agitation. Okay, another thing you can do is, number 2, what? Heat it up, that's right. If it was hot, it would mix faster. That's right, temperature. Higher temperature dissolves faster for most things, that's right. And the third one was the hardest one. Okay, crush it into smaller parts, which we called surface area, and we talked about how these little pink packets or blue packets that sometimes we put in our tea dissolve so much faster than sugar. Now, I want to go a little further than that today. Let's say that I have water and I just got water out of the sink and there's nothing in it. So I'm going to use some technical words here for my older kids. It's unsaturated right now. Wow, that's a weird word. Unsaturated. Now, sometimes you hear the weatherman talk about the clouds are saturated with rain. What does that mean? It's going to rain outside. Okay, there's lots of rain. There's a chance of it falling out of the sky. Okay? If there's not much moisture, then it's not going to rain. This is unsaturated because I don't have any sugar in it. Now watch this. I take 1 teaspoon and put it in there and I start to mix it up. It's going to take a second to mix up. Change directions. I'm going to use some, what is this called? Agitation. I'm using agitation. Look at it. It's pretty much disappearing pretty quick. Now if I stop for a second, you'll see there are a few particles that are going to the bottom. Okay? Is it unsaturated? Well, saturated means to be full. Is it full of sugar? I don't know. What I can do is I can add some more. And so I can mix it in. And so I can keep doing this. The question is, can I do that forever? No, I can't. There's a point at which I have to stop dissolving. How do I know? Because it starts sitting on the bottom. And when it's sitting on the bottom, it's not dissolving in there anymore. So if I kept putting sugar in there, and that all dissolved, so if I put a third one in there, I can keep going, okay? And it's all based on how much water I have. So this is just water and sugar, okay? So unsaturated, I didn't have anything in it. If I keep going until I have no more I can put in there, it's saturated, okay? It's totally full. Wow, if I drank that, woo! I might have to go outside and run around a little bit. That'd be a whole lot of energy. But I could still dissolve some more. So let's get the words right. Nothing in it is unsaturated. Full of sugar, can't hold any more, is saturated. And then there's this really weird one called supersaturated. And here's what that means. If I took this glass, poured it out, and I got hot water from the sink, do you think it'll hold more or less sugar than I can put in it right now at room temperature? It'll hold more, right? Hot water holds more. So if I get it really hot, let's say we get close to boiling. We get the water close to boiling. I put tons of sugar in there, right? Tons more sugar and mix, 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 mix. All of it in there, all of it in there, all of it in there. Okay? And then if I let it just sit there and don't touch it, as it comes down and it cools off, it's going to be room temperature again. Maybe an hour or so. It's holding more sugar than it should. That's called supersaturated. And we can do some really cool things with these. Okay? So, unsaturated, saturated, supersaturated. So let's do some experiments with them. We're going to build some on what we did in last episode, and then we're going to build into some other ones in the next episode, okay? So here's what we're going to do. We were talking about, we had 2 containers, and remember we had paper towels, and we had markers, okay? And we had a problem, okay? We had a problem, and here was our problem. If I had washable markers, okay, I have a blue. I'm going to do it just like I did in last episode. There's blue and red. And so what I did was I take a little bit of water and I put in this cup, okay? And I put too much. Hang on a second. Go away. That's perfect. And it's dried. Remember when I put it in there like this? We have this capillary action that runs up that. Now look what's happening, Miss Christie. Ooh, that's working even better than last time. Look at that, kids. See how it's moving up the paper towel? That's great capillary action. How is that happening? Those markers are dissolving in water. And if I leave it a long time, it'll run right up the paper towel. Okay? Sort of like all those colors that we saw at the very beginning. Okay? That worked great. Okay, so I'm going to let that sit there for a second. But we had a real problem when we were doing the other one. In the other one, I'm going to take blue Sharpie marker. That's a permanent marker. Remember we talked about that. And red. And when I stuck it in water, what happened? What happened, Miss Christie?
Nothing.
Nothing happened. It didn't dissolve. It just sat there. It was just sort of getting wet. Did it have capillary action? Man, it's working really good right now. Did it do that? No. Huh. And we said that kids' markers will dissolve in water when you go to wash your hands, but permanent markers won't. But there's sometimes ways that we can get around that. And I'm going to use a little bit of chemistry. So that means, I need to get my goggles. So let me grab my goggles. What I'm going to use is I'm going to use isopropyl alcohol, rubbing alcohol, okay? Rubbing alcohol, okay? And so I'm going to do the same thing I just did. I'm going to put some rubbing alcohol in the bottom, and it looks like water. This is why you have to be careful. Kids, let me help you out. This is so important what I'm going to tell you. A lot of chemicals, I'm a high school chemistry teacher, a lot of chemicals look like water. They're clear. They have some water in it. But this one, you don't want in your eyes, okay? There are some things that you have at your house that if you poured them out, they look like water. They're not water. They're dangerous. Always be careful, okay? Always be careful. I'm being careful with my eyes. I have my goggles on. And so I have isopropyl alcohol. Now, when I put it in water, nothing happened. Miss Christie's right. But watch what happens when I take those permanent markers and I put it into isopropyl alcohol instead of water. Oh man, look, it's starting to dissolve. Okay? So let's use the words we had from last time. Those right there are soluble in water. They dissolve. Remember that word, soluble in water. Check these out. These were not soluble. The word for that is insoluble in water, but it is soluble in this kind of alcohol, this rubbing alcohol. And you can see it's coming apart. Now, I'm not going to show you the whole thing, but let me tell you this. Some of those permanent markers have other colors. Okay, so like if you used a purple, when you put it in that isopropyl alcohol, and purple comes from blue and red, right? As it goes up that paper towel, you'll start seeing blues and reds as that purple comes apart. Okay, you take black. If you had a black, I didn't have a black Sharpie, but if you had a black Sharpie and do this with rubbing alcohol, it'll break into other colors. I know what they are, but I'm not going to tell you. I want you to try. Okay, you get to do that experiment. So there are some things that are soluble in water, and there are some things that are not soluble in water. Okay, this is insoluble in water. So here's a really good one for you. If you have little kids that have washable markers, it comes off with water. If you use a permanent marker and it gets on your hand, is water going to take it off? No, but something else might. For my older kids, there's this principle called like dissolves like. If they're like each other, they dissolve each other. What does that mean? Well, we said in one of the other episodes that water's polar and it sticks to itself. Other things that are polar dissolve into it. So let me say it like this. Polar means it has charges, pluses and minuses. Anything that has pluses and minuses in it dissolve into water because water has pluses and minuses in it. Isopropyl alcohol, rubbing alcohol, does not have charges. There are no pluses and minuses. That's why that doesn't dissolve into it. So if you get a permanent marker on your hand, I need to get that off. You could use something like hand sanitizer, rub that on there, it'd take it off. Isopropyl alcohol, just a little bit on a piece of cotton, it'll take it off. Will it take it off your clothes? Watch this. See what it's doing on the paper towel? If you got this Sharpie on your clothes and you tried to wash it, it's not going to come out, is it? But if you tried to rub something like this on there, many times it's just going to spread out. That's why you have to be careful with them. That's why sometimes they call them permanent markers, because they're permanent. Now, can you get some of them out? Sometimes. Okay? You have to dissolve it with the right thing. That's why different laundry detergents, this is your application, different laundry detergents and things. If you get things on your hands and paints, certain things take it off and certain things don't. It's all dissolving. It's all solubility. And that's how it works. Now, in the last episode, we were dealing with candy. And I love candy. So I decided we would do something else with the candy that was left over. Miss Christy wouldn't let me eat it all because I'd have a big tummy ache. So we're going to do something really cool with it. And it's an experiment you can try at home. There are 3 plates sitting up here at the very front. And she made some designs with them. And here's the experiment. We have they're all Skittles. Okay. And so what we're going to do is I have water in a bottle. So we're going to use water. And then we're going to use vinegar. Okay. And I'm going to switch those, and there's a reason you'll see in a minute. And we got to come up with a third one in a minute. So here's what we're going to do. If you did our last video, we found that sugar and the different ingredients on the top of candy, when you eat it, saliva breaks it down. Okay, it starts to break it down. That's why when you eat certain candies and you stick your tongue out, my tongue is purple. My tongue is green. Why? Because the flavorings come off. And the different food colors that they use on it come off on your tongue. Okay, and you go to eat like a snow cone and your teeth turn blue. And it's a funny looking, they have that, right? And so what we learned is this. Now I'm going to do this one. Watch how cool this one is. I'm going to show you again from last time. I'm going to take water. Miss Christy made a flour. And I'm going to pour water so there's water under all of them. We're going to watch that. We're going to compare. So I want you to watch how fast this is happening. Okay. And I'm going to get out of this so I don't make a shadow. Okay. It's starting to happen. Okay. You guys can watch it. And she's going to get a video from it. Oh, yeah. Look in the center circle. You can really see it, Miss Christy. And then it's starting to happen in the others. Look how it's starting to dissolve and the colors are starting to move toward the middle. Are they only moving toward the middle? No, I see some on the outside here. And so this water is dissolving these colors away. And so it makes this really cool flower. Again, I bet you're way more artistic than me. Miss Christy's way more artistic. But I want you to check that one out. Look how that red has gone up in the inside. Looks like a flower. Real flowers do that sometimes, right? Looks like the petal of a flower, and it let that in there. I'm going to sort of cheat and make this one do it right here. They're touching right there. If I move that just a little bit, I bet we get some red that goes through the middle of this one. And so as each of them move along, they move into each other, and the colors are mixing with one another. Okay? And so what is happening is we have all of it. It's starting to be soluble. That's awesome. Now, while that one does its thing, we're going to try this one now. We're going to try vinegar. And we're going to pour vinegar. And I told you, do you remember from the last episode what my favorite color Skittle is? It is orange. That's right. So that's why there's not very many orange. Now, check it out. Here's what I'm doing. I'm using a chemical, so I'm wearing my goggles. Okay? So I'm going to take some vinegar, but I'm going to put it in a smaller cup so I can control what I'm doing. Okay, so I'm going to pour that into a cup here that I'm going to use. Okay? Oh, that one is so cool over there. Look at the greens and the reds going together. That's so cool as it just sits there. I'm going to show you something else cool about it in a minute while it sits there. We'll pour into the middle. I'm going to do vinegar. I wonder, here's the question. I want you to make a guess. In science, it's called a hypothesis, which is an educated guess. And here's what that means. Do you think this one's going to dissolve in vinegar? I'll give you a second to think about that. Do you think it'll dissolve? Pick yes or no. We're about to find out. Here's the cool thing about science. Sometimes, a lot of times, I'm wrong. It's okay. You try again and see if you get it right. So do you think it's going to dissolve? I don't know. Let's try it out. I'm going to say no. So I'm going to pour vinegar right here in the middle. I'm going to do it just like I did that other one. I'll let it sit there. Okay? I'll let it sit there. Let's see what happens. Now, it takes a few seconds for this experiment to take off. If it's going to, it may just sit there. Let's see what's happening. Not using chemicals so I can take my goggles off. Oops, it is starting to work. My hypothesis was wrong. That's okay. I wasn't accurate. I'm starting to see the orange. Oh yeah, there go the yellows also. And so it's starting to dissolve. So the question was, is it soluble? Yes, it dissolves in vinegar. So Skittles are soluble in water from the first one, and they're soluble in vinegar. Okay? Now, which one was faster? Well, from what I was watching, I think this one was a little faster. Okay? That's called the rate of reaction. That one was a little bit faster. Now, there was a lot more Skittles. And you could say maybe they were closer together than this one. And maybe you'd have to do another experiment. Why? Buy more candy. And so you would have to try it out and try maybe the same shape and see which one's faster. But that one's really working good. Now, we have one more design because then we ran out of candy. What do you think, Miss Christie? What do you think we should use? Something else for a third liquid.
There's milk in the fridge.
Milk. Oh, that's a good one. Okay, so I'm going to get milk out of the fridge. Do I need goggles? I'm going to go with no. When I eat my cereal, I don't use goggles, okay? And so I'm going to do the same thing that we just did. And the question is this, kids, ready? Your hypothesis. Will it dissolve in milk? Think about it. Water, vinegar. I don't know, make a guess, yes or no. Ready? You got it? All right, pick an answer. Let's try it out. I'm gonna pour slow and try to keep it in that shape. And I'm gonna pour enough milk. It's right over it. All right, start the timer. So we're gonna just watch what happens. Miss Christie, I'm gonna put the milk back in the refrigerator. Let's see what's happening. Give it just a minute. It looks like no. It doesn't look like it. So the experiment looks like no. I forgot to guess. I would have said yes. You know why? When I eat cereal, the cereal changes color, right? But it doesn't look like it's doing anything. We'll leave it there and see if something happens later, but it doesn't look like it at all. It really doesn't. All right, so what we're going to do is we're just going to leave that there. Man, look how cool that one is. That one's dissolving a lot. By the way, check this out. I'm going to flip one over. Look what it looks like on the other side. It has eaten all of the color off of it. It doesn't matter what color you turn over. Blue, red, whatever. They all have changed color on the other side. Miss Christie's about to show you that. It's dissolved it away. Why is that spot there? That is where it was touching the bottom of the plate and the water couldn't get to it. Yeah, so all the colors did it. Look how cool that is. I wonder what this one does. I didn't even try these before. Turn that dude over. Yep, same thing, right? Very soluble, right? We got the word solubility. We got it. Now we're gonna do a couple more things and we're done. Okay? We're gonna come, nothing looked like happening there. All right, we'll keep an eye on that one. Here's what we're gonna do. This one's really cool. Really cool. Now, this one is gonna take a little bit more time. What we're gonna do is we're gonna take, Miss Christie, I need to get in the fridge again. Can I have an egg?
Yes.
Okay, I'm gonna get an egg. We're gonna do something really cool, kids. By the way, Miss Christie, you're not gonna get this egg back. This egg's not gonna be worth anything. What we're gonna do is we're gonna use solubility to make what I saw called a bouncy egg. How crazy is that? Okay, and so here's what happens. I'm gonna tell you the experiment, and I'm gonna need my goggles for this one. I'm gonna have my goggles, and I need to keep my goggles on the whole time while I'm doing this one. This one can get me. This is vinegar, and this one is an egg. Now, an egg, the shell of an egg has calcium carbonate. For my older kids, calcium carbonate is the same, and the calcium on it is very similar compound to what you would see if you've ever found a rock that's out on the street or something and it writes on the sidewalk. That's calcium carbonate too, okay? And so, but now that doesn't mean eggs are made out of rocks, but it's the same kind of compound. And so what we're gonna do is something really different. What happens is vinegar eats away at calcium carbonate. So I've got my goggles on, check them out. Do I look okay? Thanks. And so what I'm gonna do is I'm gonna pour it on there. And I want you to watch what's gonna happen. Pour that vinegar on there really good, and I wanna make sure I cover it, okay? And it takes a second to start reacting. And what you're gonna see is there's gonna be bubbles forming all over that egg. And so I'm going to move it a little closer to Miss Christie so she can see it. And she can start seeing there's all kinds of bubbles. I see something happening. I see something happening. Look at the Skittles. Check out the milk. Is it soluble? The answer is yes. Is it very fast? No. It's not. So one was faster than the other. So in this video, in what we were talking about a while ago, we were talking about they all dissolve at a different rate. So which one, water, vinegar, or milk, was the fastest? Water, yeah. And then the slowest? Milk. But were all three of them soluble or insoluble? They were all soluble, that's right. Now, watch what's happening here as this one's going. Now, Miss Christie will really be able to see this. There's all kinds of bubbles coming around that egg. And so what is happening is the vinegar is dissolving the shell of the egg. It's not going to touch anything inside the egg. It's just going to eat away the shell. And so the shell's going to go away. Now, this one is a longer experiment. There's all kinds of bubbles coming up there. Woo, watch this. I'm going to move it around a little bit. Okay? All kinds of bubbles. As a matter of fact, during part of it, I was doing this one yesterday because I got to show you what it looks like. And the egg will go up and down in the water. It'll get enough that it'll bob up and down. Okay? But it's going to eat the shell away. It's going to dissolve the shell. So if you've ever opened an egg, on the inside of the egg, there's a membrane. It's a clear membrane on the inside of it. And many times when you crack the egg open, that membrane stays there. Now, I'm not talking about the white part of the egg, and I'm not talking about the yellow part of the egg. I'm talking about the part that sticks on the inside of the shell. Next time you crack an egg, you'll look for it, okay? I'm going to eat all the shell away, and all that's left is that, okay? So I want to show you what this one looks like. Now, I've been letting it react for 24 hours. Here's what this one looks like, okay? It could actually go a little longer. If you let it go for about 2 days, it would turn out a lot better. Now, I want to show you what's happening. As I get my fingers down in this crazy vinegar, look at the color, okay? Now, I'm going to do this here for a second. Can you see the yellow? You can see the yellow of the yolk in it, okay? It's eating the shell away. Now I'm gonna take some water to wash off, it's got foamy stuff on it. Okay, just gonna wash that off real quick. All right, Miss Christie, you'll step back a little bit. Remember I said I'm making bouncy eggs, here it is. Eggs don't do that. It's a bouncy egg. Now, I can feel the yolk moving inside, okay? It is raw, it's not cooked. All I did was I ate the shell off of it. It dissolved it. This one's awesome. Now, this one's slow. So it took a day, a whole day, okay? Bouncy egg. Now, I'm going to prove to you it's raw, okay? Woo, this one's where it's really popular. Here it comes. Bouncy egg, bouncy egg, bouncy egg. Now, I'm going to grab a knife, and I'm going to show you what my bouncy egg looks like inside. You ready? Ready, Miss Christie? Here we go. Just going to puncture it just a little bit. And there's my egg. It's still raw. How could it be raw? Because it didn't cook it. I had a chemical reaction that dissolved away all the calcium, the shell, and all the stuff on the inside was left. That's amazing, okay? Why? Because science is cool. We're learning some cool stuff. Now, one more thing to finish out. Remember we said there are saturated, unsaturated, and supersaturated solutions? Last one, okay? Sometimes, if you've ever hurt yourself, they have what is called a cold pack. And they'll get a cold pack and they'll wrap it up and they'll snap it and there's 2 chemicals inside and it feels really good on that bruise. Oh my gosh, I'm hurting. And so you put it on there. Well, there's also what's called a hot pack. Now, this one doesn't always work for me, so I'm going to try. But it is a super saturated solution, and here's what happens. Remember we said a while ago with my water and sugar, can I add sugar forever? No. But if I get it really hot and dissolve a lot and then let the temperature come back down, it's holding more than it should. That's super saturated. Check it out. Here it is. This is a hot pack. Now, what's going to happen, Miss Christie? And you can see there's a few crystals inside. I'm going to see if I can make this thing happen. I'm going to agitate it by dropping it. Here we go. And I'm going to make that reaction really happen. And when that reaction happens, there's a disc on the inside. I can sometimes pop the disc and make it work. Sometimes, there it goes. Watch this, Miss Christie. I'll flip it over so you can see it. Look what's happening to it. It looks like it's freezing. It's not. It's crystallizing. It's making crystals. Now, it's hard for you to tell because you're watching the video, but it's hot, okay? It's really hot in my hand. This is a hot pack. That worked really good. And so you can see that disc. I'm going to let her get real close. See that little metal disc on the inside? What happens is I pop that disc and it crystallizes. So all of that shouldn't have been in there, it all turned to crystal, so it's hard. Okay, it's hard. And so, but it's giving off heat. So if I hurt myself, I can put it on there and it feels really good. But I can use this one again. So here's what I do, is I can take this, I can put it in boiling water and raise the temperature. What happens when I raise the temperature? More of it can dissolve and it'll go clear again. And if I'm really careful with it, then I can drop it on the table or snap that and I can use it again and again and again and again. It's a hot pack, saturated solution. This one is super saturated, and I made it crystallize, and when it crystallized, this chemical in here gets hot. And so I put it on there and it works great. What did we learn today? We learned that there's unsaturated, saturated, super saturated solutions. We did an experiment on the differences between Skittles dissolving into water, vinegar, water, and milk. Do they all dissolve at the same rate? No. We made a bouncy egg and we dissolved it in vinegar. That one's cool. Pick any of these, try them. If you do it, take a picture, put it down below so that I can see what you're doing. Kids, I want to see you doing it. Did you make the rainbow with the cups? Any of those things. I hope you're having a great time on Mr. Patrick's Laboratory. Can you believe it? We're going to do something else next time and it's even more fun. See you then.